for attending this webinar today. My name is Gil and I'm the GNSS product manager for Quectel. I'm working in Quectel for over a year, and prior to that I was working in various chipset manufacturer for GNSS and also for a module maker. So I'm with the GNSS technology about 20 years. I think I can answer most of the questions. Okay, so basically a few insights before we start. At Quectel, there is a huge attention from management side to bring more and more GNSS opportunities, and we are looking forward to address those issues. We have a very wide portfolio and of a solution. I will talk a little bit about our solutions, but I would like to highlight the fact that beside the GNSS, we have a very good support. So we offer a design review for the customers. Of course, this is free of charge. So we are offering a design review, and we're working with several certified antenna vendors that we certified, and we also have our own antenna group. So we are also responsible to work with and review the antenna supplier job. So totally we're responsible for everything that is related to the GNSS on your board. So these are parts of the services that we are offering, of course, free of charge to our customers. And let's move forward. Let's talk about our roadmap. So basically we have a very wide offers, starting from GPS only all the way to RTK, 1 centimeter level accuracy. Starting on the top left side, we have GPS only standard versions, and then we got GNSS. The difference between GPS to GNSS is GNSS is multi-constellation on the same time. So currently there are several constellations in the sky, and the module is working simultaneously with all those constellations on the same time. And basically the position is compute from all those systems together on the same time. Our L76 series is a standard series where we have several modules basically on the same footprint to address standard GNSS L1 requirement. Most likely, most applications is standard trackers or basic stuff, nothing so complicated. Then we got the series of the L26DR, which is basically modules that contains integrated sensors inside. And I will have a dedicated slide for this type of product. We have a dedicated timing for module, which is L26T. Over there, the application is mainly for static application, like base stations or anyone that require the timing solution. We are talking about not on the time associated with the GPS messages, but we are talking about one PPS hardware pulse, which is basically very accurate, and we're offering a very high accurate clock. The jitter is less than 5 nanoseconds, and this is definitely better than u-blox offer right now to the market. The trend today is to move from GPS or GNSS L1 only to multibands. I have a dedicated slide on the advantage of multiband as well, but basically we are the first module maker that started to work with a Broadcom chipset, and these are standalone modules that can provide around one meter accuracy. We took this product to the next level, and we integrated and we merged it with a sensor, and our algorithm is tuned to support 2 wheels, 4 wheels, dedicated UDR or ADR solution, and this is mainly for the shared mobility market. Then we got our automotive grade 1 centimeter level accuracy RTK solution, which is based on the Tessio 5 chipset. I have a dedicated slide for that as well. In the automotive grade, we got the L26DR and the 69T. Both of these modules are based on Tessio. The 26 is based on Tessio 3, and the 69 is based on Tessio 5. And then we have modules at the bottom, modules with integrated antenna on top. Anyone that can use a module with integrated antenna on top in terms of design size, I highly recommend to select this option, because then you need to spend less time on RF, less time on antenna, and going to market with a module that is integrated antenna. In some cases, it's faster than to go and design your antenna or work with and implemented an antenna on your PCB, or sometimes even with the external antenna. So it is very comfortable to work with modules with integrated antenna. So anytime that a customer is looking for the ability to switch to external antenna, so the module can basically support any options that the customer would need, either integrated antenna or external antenna. So basically, a few dry facts about the chipset and what is the expected accuracy. So basically, for example, the L76 footprint. So basically, what we are offering to our customers is basically one hardware design, and then based on the same hardware design, pin to pin, several replacements that can be switched, so the customer can go and update the features upon his requirement. So this is this slide. At the bottom, we have the LC79D. Can also go on the same footprint. The only difference that you need to keep in mind when you are working with GPS, GNSS, or L1, L4, or multiband is a different antenna. GPS only is the most simple antenna. Then you got GNSS, and then you need to support make sure that the antenna is supporting the bands, the frequencies that you want to work. And then on the LC79D, you need to attach L1, L5 antenna. Currently, we're supporting L1, L5. For next year, there is a plan, once the chipset manufacturer of the Tessio 5 will update, we are planning to support even triple band. So that's L1, L2, and L5, but this is a long way on the roadmap, and basically it's a feature that's related to the chipset manufacturer and not to us. Once they will release it, we will support it. L26, again, same footprint, based on ST Micro chipset. We got there the L26 LB, which is basically a module that comes on the same footprint, but without the sensors inside. So it's just for customers that want to do to make one hardware design and want to use this option as a low-cost replacement for modules without the sensors. So the L26DR, as in having a dedicated firmware, it's called ADR or UDR. ADR is when you are connected to the car and you can get speed or wheel ticks and direction information to the module. So assuming that you are, I have a dedicated slide on it, I will explain it in a little bit more details. Then we got the modules with integrated antenna. Again, typical application, accuracy. As a quick reminder, we also have a dedicated modules just for India. This is the L29. Basically, working with India, you must support the IRNS, which is the Indian constellation. So these are dedicated modules to support this region. High precision we can do, meaning improve the accuracy. We can basically, I would focus on the 79 and on the 69T. I've dedicated slide per each one of them. Let's talk about a little bit our most recent and powerful module. This is the LG69T based on Tessio 5, automotive grade, and basically we are having currently this is the versions that we have, but there are some updates that I'm going to share with you. Currently there are 4 different flavors. The AA is basically an RTK module for smart customers that have an external position engine. What does it mean? There are some companies in the industry which having their own position engine, and the GPS is only one sensor out of the combination, meaning they're having a camera, altimeter, a barometer, a radar, and other stuff, and basically they would like to blend all of this information with the sensors of the GPS as well. So basically these customers are having their own position engine, and the GPS acting as a sensors only, and it only provide raw data. So raw data is basically the reading of the sensors, and it's the reading of the pseudo range between the receiver and the satellite. So you can calculate your position outside. So basically the AA provide raw data of the IMU 6 axis inside and the GPS raw measurements. This goes to an external position engine, and at this stage, Quectel is not offering a position engine to our customer. So this module is mainly for customers. Typical customer will be some of these tier 1 car manufacturers. They know exactly what do they need. They know all the other sensors in the cars, what is the added value in the total navigation solution. So for example, today there are a lot of external devices that helping to navigate the car, monitoring lanes, etc., etc. So this is exactly the module these guys are using. Then we got the LG69T AP. The AP basically contains everything, and the outcome is a very accurate position. So the position engine is inside, so it says an MCU, IMU 6 axis, and a position engine. As a reminder, in order to work with RTK in the level of very high accuracy, you need to apply differential correction to the module from either a base station or RTK networks. Most of the customers today are using planning to use RTK service provider network, and this service costs money. So the customer has to implement some IP connectivity to these networks and apply for these corrections. On the right side, we're going to have the AB, which is ASIL B compliant, and this is mainly driven by the automotive self-autonomous cars industry. And this is extremely complicated module that has to support this level of spec. And this is, and again, right now there are a lot of talkings about this, but yet the market is not there because this is very high-end solution, and there is a huge amount of money that the customers would have to certify each part that is going to be in these autonomous vehicles. The AF, or it's going to be a different version of the AAA, is basically a cost reduction of the AP, and we're going to do most of the features of the AP are going to be on the internal resources of the chips, so there is no need for an external MCU, meaning there is a cost reduction. It will not provide the same feature list as the AP, but it's going to provide high accuracy position and accept RTK inside, and there is going to be a position engine inside. but there are some differences between the AP and the version that is not going to have the MCU. Timelines, which is more or less right now, we started to deliver customer samples. AA is already in the market. Customers have already started to evaluate it. Let's talk about any questions so far, guys?
I don't see any yet, so in case you would like to ask something, you can raise your hand.
Okay. Let's talk about our LC79D series. Basically, this is the first module in the market based on Broadcom chipset. We took this module, which standalone accuracy of 1.2 meters, and we add to it externally over I2C an IMU of 6 And then we took and we wrote a dedicated firmware for this module in order to support a very big demand in the shared mobility market. So basically, you guys can understand that we are talking with the biggest names in the industry, and these requirements arrive from some of the companies that are based in North America, actually in California. And their requirement was we want to have 2 wheels driving in in the center of San Francisco, in the commercial area, where there's a very high big building and a lot of distortion. And we want to achieve a very good accuracy with a standalone receiver. So we made a very big R&D group that allocated to solve these issues. And recently we have released these firmwares to the market. And this is this type of solution. So basically you can either get it in a standalone version or with a dedicated 2 wheels, 4 wheels firmware. As a reminder, the sensors are outside. On our roadmap, which we already have the engineering samples, we are going to release the module based also on Broadcom chipset. But the advantage is that the sensors are going to be integrated inside the module. So it's going to be a little bit more easier for the customer to work with that. So this is coming soon to the market. These are ours. Just let me see, no more to add about it. So basically this module working in multiband, we sold it already in India as well, and all across the world. But as I remind you, standalone accuracy around 1 meter, and then we took it to the next step with a very advanced firmware. We're even planning to release a firmware that is going to support 100 Hertz update rate of the module and the sensors together, but this is coming later on this year, but this is on our roadmap. These are standard L76 footprint modules based on MediaTek, Aurora chipsets, standard modules with extra LNA or only ROM version. L76, again, same footprint, drop and replacement modules. So customers can do one hardware design, and then upon use cases, they can replace their module. So basically, a lot of times we're getting a requirement. Okay, we made a GNSS module with 3 constellation, and then there is a need either to add an external LNA or to do a cost reduction. So basically we do a cost reduction by switching the internal chipset. So we go down from 3 constellation into 2 constellation, and in a very aggressive pricing. So customers can, in some of the cases, can enjoy this good performance with only two constellations. L26 footprint. So we're having several modules. The DR is, which I will talk a little bit about it later on a dedicated slide. The DR that contains the sensors inside, and then we got the T for the timing, and then we got the L26 and the L26LB, basically the same idea of doing a cost reduction. So the customer can design one hardware, then he decide, no, I don't need the module with the sensors. I can just do a drop-in replacement, and in order to do cost reduction, then we offer the L26 or the L26LB. These are our series of modules with integrated antenna on top. Each one of them is also supporting an option to work with external antenna. Our modules that are beside the one that is dedicated for India are based on MediaTek, which their current name is Aroha. So they are based on Aroha chipsets, and these are mainly for standard applications. But again, I encourage each one of you guys to try a model with integrated antenna. In terms of design and go-to-market time, this is the right solution. If you have the right height to support this size. As a quick reminder, the enclosure of the product cannot touch the antennas because it will cause to a shift in the frequency. So therefore, nothing can touch the antenna. This rule applies for any GNSS design. Nothing can touch the antenna. This is our latest module that we have released to the market. Same footprint with two constellation in a very, very aggressive price range, and there is a very good feedback from the market regarding this module. Talking about multi-bands. So for the multi-band, dual band, as I said, right now we are working L1, L5, supporting L1, L5, and then we have the LC79D based on the Broadcom chipset, and the L89 supporting GPS GLONASS Galileo and the Indian IRNS based on the Tessio chipset, and our L89T, 69T, sorry, based on Tessio 5, the most advanced module that we are offering to the market. Okay, any more questions before I switch into technology, talk about a bit more details, DR, things like that?
Well, I don't see any.
Okay.
Pavel, Kovac, do you have anything, or will we wait for the end?
We will wait till the end.
Okay, thank you.
Okay. So in terms of technology, basically in the beginning, there was only the American satellite constellation, which is well known as a GPS. So when you say GPS, you are referring to the American GPS constellation. Later on, the Russians have launched their own satellite constellation, which called as GLONASS. After the GLONASS, the European have launched the Galileo plan, and then the Chinese have started their own satellite constellation, which is the IRNS. Sorry, the Baidu, and then the Indian have, these are the latest one, they have released the IRNS satellite constellation. There is also another constellation right now, which is the Japanese QZSS, which right now it is an augmentation system, and they are planning to switch it to be an active navigation system, but we are not yet there in terms of the receivers. So as a reminder, it is the same satellite that are transmitting in various bands. So when you're talking about a multi-band, you're talking about signals that are getting out from the same satellites. It's just different bands. And today, what is the advantage of working in the GNSS versus GPS? When I work in GNSS mode, I got usually the accuracy is better. I have much more satellites in the sky. So in case there is a line of sight for a certain satellite constellation, most likely that I will be able to track another satellite constellation. And integrity, I have plenty of others, plenty of satellite constellation. So basically there are so many satellites right now in the sky that I feel enough confidence to work and track signals in places I couldn't do tracking before. The most advanced feature is when we are working with multiband, and over there, the advantage of working in multiband is basically two things, which is very easy to remember. One of them is improved accuracy, and the other one is multipath rejection. And multipath is a condition when the signal from the satellite hit the surface and jump once again into the receiver antenna. So basically, this is typical when you are working in a very dense urban canyon environment or beside reflective surfaces like metal, water, or glass that are, water is the most reflective surface, by the way. So when you're working beside these surfaces, the signal from the satellite goes once again into the receiver. In some cases, when let's say that you're working in a very tough environment, let's imagine like trying to get a GPS lock in New York City. So sometimes you don't even see the satellite; you just see the reflection of the signal from different surfaces. So this is called multipath, and it's very difficult for the module to work in this environment. And adding the second band just improves the solution, and it can work in these conditions. Okay. So again, working with the several constellations at the same time, improved accuracy and much better conditions and much more tracking capabilities. So basically at Quectel today, we are offering a variety of modules all the way from standard accuracy of 2 to 5 meters, all the way down to the centimeter level, talking about our RTK offering to the market. We talked earlier before about the modules and the integration of the sensors. So what is the advantage of using the sensors? Basically, there are conditions where we just don't have satellites track anymore, like going into a tunnel or driving in the underground garage or under the bridges or conditions like that, when actually we don't have whatsoever line of sight to the satellite, and therefore we cannot track satellites. In these conditions, it's a pure fact that using the sensors will only maintain the position and enable me to get continuous tracking. So there are two modes that we are working on them and supporting them. One is ADR and the other one is UDR. So UDR is when you're connected to the car and you're getting some type of speed information. We call it wheel ticks. You can get it either from the wheels or from the RPM or you can actually feed it in a software command, and then we are getting the speed. The other information that we need is basically direction. So we know if we are driving forward or we are driving reverse. And exactly, so, I mean, as a reminder, this is not very high-end sensors, but it will keep you to maintain your location for several minutes. And basically, the module is driving with the sensors always on. And while there is a very good signal condition, the position engine is using the sensors less and less. When there is a very bad signal condition or completely lost of GPS signal condition, then the weight of the sensors inside the position engine becoming more and more critical. So basically, in a tunnel, there is no satellite, and therefore the weight or the weight of the sensors inside the position engine is very high, meaning the position engine is completely using the sensors input, and it doesn't use the GPS input because there is no GPS at all. So these are the two features. It's called ADR and UDR, and basically these are the units that we are offering. Again, the L26DR is automotive grade. If you don't need the automotive grade, then we got with sensors for a standard, for improved accuracy. Then we got the L79 and its replacement, which is the L29 module with integrated sensors. So this is the advantage of using sensors inside the module. The next technology that I would like to speak about is RTK. So basically, it's not enough that we have a very high-end receiver. We also need to get corrections in any given time that the module is working. So basically, today we see more and more and more applications that are requiring to work in this accuracy. A lot of applications that we have not seen before, like even self-driven robots or agriculture stuff that like someone wants to sit on his backyard, drink beer, and the robot should cut the grass on his backyard, in his backyard. So they planning to use those RTK modules. And in order to work in this mode, you need to get, as long as the module is working, you need to get an RTK corrections. So RTK corrections can arrive from two different places. It is either from a dedicated base station. This is something we are also going to offer to the market. So we are giving you a dedicated base station, and you need to maintain a constant data streaming from the base to the rover. So basically, you need most likely we will encourage you to use one of our cellular modules to deliver the stream of data from the base station to the rover unit. The disadvantage of the system is that you are dependent on the distance between the base and the rover unit. In other words, you're limited, the high accuracy is limited to the distance between the base station and the rover. But these corrections are free of charge, and you just basically pay for airtime to deliver the data between the base and the rover. A typical application example for such a thing, let's say that you have a golf court, and you have like 500 different cars that are driving in the golf court, and you want to provide them very high-end accuracy to each of the cars. So most likely the right approach to address this issue will be to buy a base station and to transmit the corrections over cellular media or even RF between the base station and the rover. Customers that cannot use a base station, for example, if you are driving a car from Austria all the way to, I don't know, to Munich, then of course you cannot use one base station. So the other way around is to use the RTK network providers. And as a reminder, the RTK service of these suppliers cost money. So you have to pay A, for the airtime to get the data. B, you have to pay for the data itself. Currently, there is no fixed price and for these services, and it's mainly depends on your type of application and on the quantity of modules that you would like to connect to the network. At this stage, we are not offering this type of services. And as I said, at this stage, but we're highly considering to offer this service as well to our customers. It is something that I'm working on it. And hopefully within a month or two, we will be able to share with you more information about this specific issue. So going back as a reminder, how do we supposed to work with these RTK corrections? So I told you about the AA. So the AA is basically some type of sensors that provide an output of a raw measurements to the application processor. So the RTK corrections, either from the service provider or from the base stations, are coming through the air over LTE or any other media, 2G, 3G, 4G, whatever you have in your hand. Then these corrections are getting into the application processor. The application processor has a position engine inside, and it blends between the various inputs of sensors, GPS, car speed, directions, all of that and other sensors, and he has the position engine to calculate the position. So the outcome of this slide is that the AA basically provide raw data and the RTK corrections are applied directly into the position engine. The other way around is if we have the LG6090 AP version. So on the AP, the position engine is inside. So basically we are getting the same RTK corrections, but this time the corrections are going directly into the module instead of to the application processor. And the outcome between the GPS and the application processor is basically the output of the high precision positioning. And we are getting inside to the module where we will get the direction and the car speed. Okay, so this is for the AP, which contains a position engine inside. The following slide talks about, as I told you, there are some benefits of using the multi-band versus the stand L1 only. So the outcome of this slide, which you mainly need to remember, is the multipath rejection and the accuracy, the high-level accuracy. Also, I want to talk about GNSS. GNSS is not only for positioning. We are getting also, for example, right now over the Galileo, there is some type of rescue service that we're going to get acknowledgement from the rescue service over the Galileo satellite constellation. For example, someone activated an alarm that he needs a rescue, and the rescue has been transmitted whatever media, and once it gets into the control station can activate some type of acknowledgement message over the Galileo signaling. So basically, the acknowledgement to the guy that activated the rescue request can be transferred via the Galileo satellite constellation. And we are going to, and later on there are going to be a same signaling mechanism over different frequencies. So for example, this is going to be as well the situation with the Indian IRMS. They are also going to support this rescue acknowledge signaling over their satellite constellation. So again, the satellites constellation are not using only for navigation and positioning, but also for other tasks as well. So this is our view of the market. I focused on the mainly most common application. We do have other things that we're working on them. For example, secure GNSS for tachograph application for digital tachograph. This is a different market that Quectel is working on it and investing time and R&D resources. At this stage, we are not yet decided to release the information to the market, but this is something that we are also working on it. So this is most likely the typical verticals today in the market. So we see the personal trackers and pet trackers for pet is a growing up vertical. Many customers are going after this welfare of the pets, and are using those smart trackers. Sport activities become a major in our life, and a lot of people are tracking their sport activities. Vehicle trackers, that's the bread and butter. That's the one of the biggest driven vertical in the segment in the market, and these are the standard vehicle trackers. It's either the UDR, ADR, or any standard trackers that is using to track your shipments. ADAS and self-driving, this is a very high-end solution where we are seeing the RTK solution, but the market is not yet there. Everyone wants to see that we're having a roadmap to support this vertical, but the market is not yet there. Shared mobility is a huge vertical where we see a lot of receivers, all those shared bikes, shared motorcycles, shared transportation. When people want to track not only the location, but they also want to track the behavior of the driver. For example, if they go on forbidden areas and stuff like that, that's the reason they need such a high accuracy on these receivers. Smart agriculture and robot and delivery robots, that's a very big vertical that we are facing, and very active in this market. Okay, I think that these are my slides, and if there is a Q&A questions, I would like to address them right now.
Okay, there were one with about the RTK detail abbreviation, sorry, but it was answered already. So, and I see one question. We are going back to modules with this question, because a question is that, is there a comparison chart or grid where the L70 or better L80 modules, meaning to see what is or are differences between L80 and L80R besides missing input for external antenna? And yep. Hello?
Yeah, so this is the L80 and L80R. R is basically both of them are supporting GPS only. The R is basically the ROM version, because this is a different chipset that contains flash inside. This is the ROM only version. So this is the difference between the L80 and the L80R.
Okay.
Different chipset.
Okay, I hope we answered it to be satisfied, the Mr. Trevenka. And well, I do not see any more questions. We had yesterday, but we answered it quite long by emails. And thank you for that, Gil, and for your colleagues that answered that. So if I will have any questions after webinar, I will resend it to you. And I also would like to encourage all our attendees that please send the questions.
As a last reminder, we do have a dedicated EVK per module. So the customer can evaluate the performance and it doesn't need to work on direct module, but you can use the reference kit to evaluate the performance and do the software integration on these EVKs. Okay. Okay, so I'm stop sharing, and thank you all for attending my class.
Okay. Okay. Well,
Okay.
I just add that the recording from this webinar will be published on our web pages as usually free on demand. So follow us on social media or our newsletters. And I'd like to thank you, Gil, for an interesting and detailed webinar presentation. And yeah, I see that uh, Beat added some information to your chat, so you can see it all. And well, at the end, thank you all who joined us during our event and stay with us. Tomorrow, we have the final part of our webinar marathon about communication network. The last one is about LPWA communication modules network. So tomorrow again at 11 a.m. If you are registered, you will be notified accordingly. And well, thank you and wish you a pleasant and successful day. Goodbye.